points on the curve y equal to 12x minus x cube at which the gradient is 0 are option A 0, 2, 2, 16, option B 0, minus 2, 2, minus 16, option C 2, minus 16, minus 2, 16, and option D 2, 16 and minus 2, minus 16. We are given the curve y is equal to 12x minus x cube. We have to find points on this curve at which gradient is 0, that is slope of the tangent should be 0. Slope of tangent we know it is given by y dash, and y dash, and you differentiate this, we get 12 minus 3x square, and this becomes equal to 0 when x square is 4 or x is plus or minus 2. So x coordinates of the point where slope of the tangent is 0 should be 2 or minus 2, and when x is 2, 24 minus 8, y coordinate will be 16, and when x is minus 2, it's a odd function, so it will be minus 16. So at the points 2, 16 and minus 2, minus 16, slope of the tangent or gradient will be 0. So answer is option D. Next question. The area of the triangle formed by the coordinate axis and a tangent to the curve xy is equal to a square at the point x1, y1 on it is option A square x1 by y1, option B a square y1 by x1, option C 2a square, and option D 4a square. We are given the curve xy is equal to a square, and we are asked to find area of the triangle enclosed by a tangent at the point x1, y1 on the curve. We are asked to find the area enclosed by the tangent with the coordinate axis at the point x1, y1 to the curve xy is equal to a square. From coordinate geometry, we can see that this is a rectangular hyperbola. We can do this question very easily in coordinate geometry. Tangent at any point x1, y1 is given by xy1 plus yx1 is equal to 2a square. This 2xy term, we will use s1 is equal to 0, s1 will be replaced by xy1 plus yx1 is equal to 2a square. So from there, we can see x-intercept is 2a square by y1 and y-intercept is 2a square by x1. If I bring the 2a square to the other side, it is x by 2a square by y1 plus y by 2a square by x1 is equal to 1. So x-intercept is 2a square by y1 and y-intercept is 2a square by x1. Now we can see a right angle triangle, and area it is equal to half into 2a square by x1 into 2a square by y1, and also we know x1, y1 is a point on this curve. So x1, y1 will be equal to a square. x1, y1 we can replace it by a square, and answer becomes a square gets cancelled, 2 gets cancelled, 2a square. Area of the triangle is 2a square, which is option C. Next question. The slope of the tangent to the curve x equal to t square plus 3t minus 8 and y equal to 2t square minus 2t minus 5 at the point 2, minus 1 is option A 22 by 7, option B 6 by 7, option C minus 6, and option D none of this. We are asked to find slope of the tangent for the curve x equal to t square plus 3t minus 8 and y equal to 2t square minus 2t minus 5 at the point 2, minus 1. This curve it is given in parametric form. You can see x is given as a function of time, y is given as a function of t, and coordinates of the point at which you have to find a slope is given as 2, minus 1. That is, x coordinate is 2 and y coordinate is minus 1. We can find the corresponding value of t, solve both the quadratic equations, and the common root of the quadratic equations will be the value of t, for which we can multiply this equation by 2. 2t square plus 6t is equal to 10 when multiplied by 2 becomes 20, and 2t square minus 2t is equal to 4 from the second equation. Subtracting both of them, we get 8t is equal to 16 or t is equal to 2. So, when we say the point 2 comma minus 1, we are finding slope of the tangent at which the parametric value t is equal to 2. Now, at this point, slope of the tangent is given by dy by dx. Dy we can see differentiating this 4t minus 2 divided by dx on differentiating this 2t plus 3 and substituting t equal to 2, we have 6 by 7. So, slope of the tangent would be 6 by 7, which is option B. Next question, the point of the curve y square is equal to 2 into x minus 3 at which the normal is parallel to the line y equal to 2x minus 1 is option A 5 comma 2, option B minus half comma minus 2, option C 5 comma minus 2 and option D 3 by 2 comma 2. We are given the curve y square is equal to 2 into x minus 3 and we have to find the coordinates of the point on the curve at which the tangent is parallel to y equal to 2x minus 1. That is, slope of the tangent we want it to be 2. Slope of tangent we want it to be equal to 2. And we want coordinates of the point on the curve y square is equal to 2x minus 3 at which slope of the tangent is 2. Differentiating this, 2y dy by dx is equal to 2. Differentiate the curve. Derivative of y square 2y dy by dx is equal to 2. 2 gets cancelled. Dy by dx is 1 by y and we are finding coordinates of the point at which slope of the tangent is 2. So, dy by dx is 2 or y is 1 by 2. So, y coordinate at which we are finding tangent is half and substituting that 2 into x minus 3 is equal to 1 by 4 or x minus 3 is 1 by 8 or x is 25 by 8. So, the coordinates of the point are 25 by 8 comma 1 by 4, which is option B. Next question, the line x plus y is equal to 2 is tangent to the curve x square equal to 3 minus 2y at the point option A 1 comma 1, option B minus 1 comma 1, option C root 3 comma 0 and option D 3 comma minus 3. We have to find the coordinates of the point at which the curve x square is equal to 3 minus 2y. We have to find coordinates of point on the curve x square is equal to 3 minus 2y at which tangent is x plus y is equal to 2. Now, you can see this curve is a parabola. We can do this question as well in coordinate geometry. Let us use calculus approach for it. We have to find coordinates of a point on this curve. Let the point be x1 comma y1. x1 comma y1 is also a point on this tangent. So, y1 is equal to 2 minus x1. So, I can assume the point to be x1 comma 2 minus x1. Differentiating this, 2x is equal to minus 2 dy by dx or dy by dx is equal to minus x, and at this particular point dy by dx will be minus x1. So, equation of the tangent would be y minus 2 minus x1 is equal to minus x1 slope of the tangent into x minus x1. Y minus y1 is equal to m into x minus x1. Now, let us see what will this equation come out to, and it is given that this equation is x plus y is equal to 2. So, we have to find the value of x1 such that this equation comes out to x plus y is equal to 2. Let us simplify this equation. Y coordinate, y term is y plus x1 is equal to, we have minus 2, take it to the other side, it becomes plus 2. We have plus x1 here and x1 square there. Now this equation should be same as x plus y is equal to 2. Y coordinate, y term is y here, it is also y here. So x coefficient should be 1 in this. So x1 has to be equal to 1. And x1 is equal to 1 will gives us this value to be 2, and it is also 2 here. So this line will become tangent to this curve at the point x1 is equal to 1, and y coordinate at that point would be 2 minus x1, which is also 1. So answer for our question would be point 1 comma 1, which is option A. Another approach for this question is algebraic approach, in which a polynomial curve y is a polynomial in terms of x will have this particular line as a tangent. When we solve this line with the curve, we get a polynomial equation with repeated roots. For a line to be a tangent to a curve, both the curves when solved, we should get a repeated root. Let us solve the line with the curve. X square is equal to 3 minus 2 into y, I can replace it by 2 minus x. So this will be x square plus 2x, on the other side it will become minus 2x. 3 minus 4 is minus 1 plus 1 is equal to 0. So root of this equation, this has repeated roots, x minus 1 whole square equal to 0, and the root is x equal to 1, and when x is 1, y should also be 1, or our point is 1 comma 1. So on the curve x square is equal to 3 minus 2y, at the point 1 comma 1, tangent equation would be x plus y is equal to 2. So again it's option A. Next question, if x equal to t square and y equal to 2t, then equation of the normal at t equal to 1 is option A, x plus y minus 3 equal to 0, option B, x plus y minus 1 equal to 0, option C, x plus y plus 1 equal to 0, and option D, x plus y plus 3 equal to 0. X equal to t square and y equal to 2t. We are given the curve x equal to t square and y equal to 2t, and we are asked to find the normal, equation of normal at the point where parametric coordinate t is equal to 1. We are asked to find normal to the curve x equal to t square and y equal to 2t at the point whose parametric coordinate is t equal to 1. Now very simple question, y minus y1 is equal to m, slope of the normal, which is minus dx by dy. Slope of the normal, we know it is given by minus dx by dy. Differentiate x with respect to t, minus 2t by 2 into x minus x1. X minus x1 is t square, and this we want at the point where t is equal to 1. So y minus 2, put t equal to 1, is equal to minus of x minus 1, which makes it x plus y is equal to 3. So equation of the normal is x plus y equal to 3, which is option A. Next question, the equation of the normal to the curve y is equal to sin pi x by 2 at 1 comma 1 is option A, y equal to 1, option B, x equal to 1, option C, y equal to x, and option D, y minus 1 is equal to minus 2 by pi into x minus 1. We are asked to find normal to the curve y is equal to sin pi x by 2 at the point 1 comma 1. Now we know equation of the normal is given by y minus y1, y coordinate at the point is 1, is equal to m into, m is slope of the normal, which is minus 1 by dy by dx, minus 1 by dy by dx. Differentiate this, dy by dx is derivative of sin pi x by 2, which is cos pi x by 2 into pi by 2 into x minus x1. But observe, at x equal to 1, cos pi x by 2 becomes 0. So we should not represent slope of the normal in this particular format. We can see slope of tangent is 0. So slope of normal, the term slope of the normal do not exist, or this quantity tends to infinity. That indicates that this line is parallel to y-axis. Normal will be parallel to y-axis. So normal is a line parallel to y-axis and passing through the point 1 comma 1. So its equation would be x equal to 1. In the same term, if I replace reciprocal of this to be 0, if I take this term the other side, this entire quantity would become 0. X minus 1 will be equal to 0, or x equal to 1 will be equation of normal, which is option B. Next question. The equation of tangent to the curve y equal to 2 cos x at x equal to pi by 4 is option A, y minus root 2 equal to 2 root 2 into x minus pi by 4. Option B, y plus root 2 equal to root 2 into x plus pi by 4. Option C, y minus root 2 equal to minus root 2 into x minus pi by 4. And option D, y minus root 2 equal to root 2 into x minus pi by 4. We are asked to find tangent to the curve y is equal to 2 cos x at the point x equal to pi by 4. Equation of tangent, we know it is given by y minus y1. y1 is y coordinate at the point where x is pi by 4. So substitute pi by 4 in place of x. Cos pi by 4 is 1 by root 2. Y is root 2. So y coordinate at that point is root 2. Y minus root 2 equal to slope of the tangent. Slope of the tangent is given by derivative of y dash is minus 2 sin x. Minus 2 sin x at x equal to pi by 4 will be minus root 2. Sin pi by 4 is 1 by root 2. Minus 2 sin x will become minus root 2 into x minus x coordinate of the point is pi by 4. So this will be equation of the tangent, and when we simplify this, equation will be in the form y minus root 2x, throw it to the other side, it will become root 2x is equal to, send this root to the other side, this is root 2 pi by 4. So equation of the tangent is root 2x plus y equal to root 2 plus root 2 pi by 4. Answer is y minus root 2 equal to minus root 2 into x minus pi by 4, which is option C. So our right answer is option C. Next question. At which point the line x by a plus y by b equal to 1 touches the curve y equal to b e power minus x by a? Option A 0 comma 0, B 0 comma a, C 0 comma b, D b comma 0. We need to find coordinates of the point at which the line x by a plus y by b equal to 1 touches the curve y is equal to b e power minus x by a. This question can be done in many ways. To answer that question, you can just look at the options a comma 0, 0 comma a, b comma 0 and 0 comma b. Except for 0 comma b, no other point satisfies these equations. Even the tangent equation is not satisfied by any other point other than 0 comma b. So answer has to be C 0 comma b. But for the sake of understanding of this question and to do this question, let us see how to find coordinates of a point given such question. Forget the options. From x by a plus y by b is equal to 1. If we know that it is tangent to this question, a curve, then how to find coordinates of the point at which this is the tangent? We know from this equation, slope of the tangent line is minus b by a. Slope of the tangent line is minus b by a. Slope of the tangent at any point on the curve is given by dy by dx. Differentiate y dash is equal to minus b by a e power minus x by a. E power x by a minus derivative is minus of e power minus x by a into 1 by a, b as it is. So derivative will be minus b by a e power minus x by a. Now slope of the tangent is given to be minus b by a. So we want this quantity to become 1. It becomes 1 when x is 0. So x coordinate of the point should be 0, and putting x equal to 0, y coordinate of the point is b. X coordinate of the point is 0, So putting x equal to 0, y coordinate of the point is B. So the line is tangent to the curve at the point 0, B. Answer is option C. Next question. Find angle between the curves y square is equal to 4x and x square plus y square equal to 5 at the point 1, 2. Option A, tan inverse 3. Option B, tan inverse 2. Option C, pi by 2. And option D, pi by 4. We are given the curves y square is equal to 4x and x square plus y square is equal to 5. This is a circle centered at origin, and we have a parabola, and in the question itself we are given the point of intersection as 1, 2, so we need not solve the curves. Otherwise y square we would have replaced it by 4x. We will get a quadratic equation in x. We will solve. We get two values of x. Substituting one value, x negative we can ignore, and positive value of x will give us two values of y. That is how we get point of intersections to be 1, 2 and 1, minus 2. So because point of intersection is already given, we will just verify if it is right. 1 plus 4 is 5. 1 into 4 is 4. 2 square is 4. So it is a point which satisfies both the curves, and that is the point of intersection. At this point, we are asked to find angle between the curves. Angle between the curves is given by angle between the tangents. Let us find the slope of the tangent m1 for the first curve. Y square is equal to 4x. Slope of the tangent is given by differentiation. Differentiate this curve. 2y dy by dx is equal to 4, or dy by dx is equal to 2 by y, and y coordinate is 2. So slope of the tangent is 1. For the second curve, again on differentiating, 2x plus 2y dy by dx is equal to 0. 2x plus 2y dy by dx is equal to 0. Our dy by dx is minus x by y. X coordinate is 1, y coordinate is 2. So slope of the second tangent is minus 1 by 2. So we have tangent lines for both the curves, 1 and minus 1 by 2. Angle between tangents tan theta, we know it is equal to modulus of m1 minus m2 by 1 plus m1 m2. Substituting m1 equal to 1 and m2 equal to half, we have tangents tan theta to be equal to 3, or angle between the tangents is tan inverse 3, which is option A. Next question. For the curve by square is equal to x plus a whole cube, the square of subtangent is proportional to option A, subnormal whole power half, option B, subnormal, option C, subnormal whole power 3 by 2, option D, none of this. For the curve by square is equal to x plus a whole cube, we need to find to which power of subnormal subtangent whole square is proportional to. We know the formula for subtangent and also for subnormal. Subtangent for any curve, it is given by modulus of y coordinate at the point, divided by dy by dx, and subnormal is given by y coordinate at the point into dy by dx. So let us find what is y into dy by dx and what is y by dy by dx for this curve. Differentiating, we have 2by dy by dx is equal to, derivative of this, 2by dy by dx is equal to 3 into x plus a whole square, or y dy by dx is equal to 3 by 2b into x plus a whole square. Y dy by dx is equal to 3 by 2b into x plus a whole square. So length of the subnormal we have 3 by 2b into x plus a whole square. Let us also find length of the subtangent. Length of the subtangent will be equal to y by dy by dx, that is dividing y square by this quantity. Y by dy by dx is nothing but y square by y dy by dx. Dividing y square by this quantity, we have 3, 2b goes up, x plus a whole square, and from this curve we know by square is nothing but x plus a whole cube. So, this quantity will be equal to by square, we can replace it by x plus a whole cube, x plus a whole square gets cancelled, 2 by 3 x plus a. So, subtangent length is 2 by 3 x plus a, subnormal length is 3 by 2b x plus a whole square. So, subtangent whole square is nothing but 4 by 9 into x plus a whole square. We can see that x plus a whole square term is common in both. So, subtangent whole square is proportional to subnormal. So, power of subnormal is 1. Subtangent whole square is proportional to subnormal. It is option B. Next question. The tangent to the curve y is equal to ax square plus bx at 2 comma minus 8 is parallel to x axis. Then option A equal to 2, b equal to minus 2. Option B, a equal to 2, b equal to minus 4. Option C, a equal to 2, b equal to minus 8. And option D, a equal to 4, b equal to minus 4. We are given the curve y is equal to ax square plus bx, and it is also given that the tangent at the point 2 comma minus 8 is parallel to x axis. Tangent at the point 2 comma minus 8 is parallel to x axis. That is, slope of the tangent at this point is 0. Slope of the tangent we know it is given by dy by dx. Differentiate the curve. Dy by dx is 2ax plus b, and this is 0 when x is equal to 2. So, substituting x equal to 2, we have 4a plus b is equal to 0. Call this equation number 1. We have 4a plus b is equal to 0. And for us to have a tangent at this point, first of all, this point should satisfy the curve equation. So, substituting the point, we have substitute 2, 4a plus 2b is equal to minus 8. Substitute the point here, 4a plus 2b is equal to minus 8. So, from these two equations, we can happily get the value of a and b. Subtract one equation from the other. B you can see is minus 8, and a value minus 8, take it to the other side, a value is 2. So, a is 2 and b is minus 8, it is option C. Next question. The sum of intercepts and coordinate axes made by the tangent to the curve root x plus root y is equal to root a is option A, option B 2a, option C 2 root a, option D none of these. In this question, we are asked to find sum of the intercepts made by any tangent line on coordinate axis. We want sum of these two intercepts. Let any point be x1 comma y1. Let any point be x1 comma y1. At this point, tangent equation is given by y minus y1 is equal to m, slope of the tangent. Slope of the tangent is dy by dx. Differentiate 1 by 2 root x plus 1 by 2 root y dy by dx is equal to 0, or dy by dx is equal to minus root y1 by root x1 into x minus x1. This is the equation of the tangent line at the point x1 comma y1, and what we need is sum of the intercepts. Sum of intercepts. Let us see what is x-intercept. For x-intercept, put y equal to 0, y1 minus y1, root y1 gets cancelled, minus minus gets cancelled, root y1 root x1 plus x1. So, x is equal to root x1 into root y1 plus x1. what we are doing is putting y equal to 0, minus n gets cancelled, root y1 gets cancelled, we are left with root y1 here into root x1 is equal to x minus x1, or x is equal to x1 plus root x1 root y1. And for y intercept, put x equal to 0, root x1 gets cancelled, we have root x1 into root y1, minus n gets cancelled, that is y minus y1, or y intercept will be y1 plus root x1 root y1, which we can write it as 2 root x1 y1. So, sum of the intercepts is nothing but x1 plus y1 plus 2 root x1 y1, which is nothing but root x1 plus root y1 whole square. And because x1 comma y1 is a point on the curve, root x1 plus root y1 is root a, and root a whole square is a. So, sum of the intercepts, it is equal to a, which is option A. Next question, find coordinates of a point on the curve y is equal to x log x, at which the normal is parallel to the line 2x minus 2y equal to 3. Option A 0 comma 0, option B e comma e, option C e square comma 2e square, option D e power minus 2 e power minus 2. We are supposed to find coordinates of the point on the curve y is equal to x log x, where the normal is parallel to the line 2x minus 2y is equal to 3. So, for the normal to be parallel to 2x minus 2y equal to 3, slope of the normal should be 1. Slope of normal is 1, or slope of tangent should be minus 1. For slope of normal to be 1, slope of tangent we know it should be minus 1. Slope of tangent, it is given by dy by dx, differentiate y dash or dy by dx is, apply UV rule, x into derivative of log x is 1 by x plus derivative of x is 1 into log x, or y dash it is 1 plus log x, and this is equal to minus 1, or log x is equal to minus 2, implies x equal to e power minus 2, x equal to e power minus 2. So, x coordinate of the point which we want is e power minus 2, and y coordinate would be, substitute x coordinate here, e power minus 2 into log of e power minus 2 is minus 2. So, y coordinate would be minus 2 e power minus 2. So, coordinates of the point where slope of the normal is equal to 1 or slope of the tangent is equal to minus 1 is e power minus 2 comma minus 2 e power minus 2, which is option D. So, write option D. Next question, if normal to the curve y is equal to f of x is parallel to x axis, then correct statement is option A dy by dx is equal to 0, option B dy by dx is equal to 1, option C dx by dy is equal to 0, or option D none of this. We are given that normal is parallel to x axis, normal is parallel to x axis, and when normal is parallel to x axis, minus dx by dy is 0. So, dx by dy has to be 0, it is option C. Next question, the length of normal to the curve x equal to a into theta plus sin theta, y equal to a into 1 minus cos theta at the point theta equal to pi by 2 is option A 2a, option B a by 2, option C root 2a, option D a by root 2. We are asked to find length of normal to the curve. The curve is again given in parametric coordinates. X is given as a function of theta, y is given as a function of theta, and we are asked to find length of the normal at the point theta is equal to pi by 2. Length of the normal, we know it is given by y1 root over 1 plus m square. Length of normal, it is given by y1, which is y coordinate of the point, into root over 1 plus m square, and as length is positive, we always have to put a mod towards the end. And at theta equal to pi by 2, y coordinate is, when theta is pi by 2, cos theta is 0, y coordinate is a, root 1 plus m is dy by dx. dy by dx, differentiate a into derivative of 1 minus cos theta is sin theta. So, dy by d theta is a sin theta, and dx by d theta is a into 1 plus cos theta. So, a gets cancelled, and slope is sin theta by 1 plus cos theta at any point, and when theta is equal to pi by 2, we can see sin pi by 2 is 1, cos pi by 2 is 0. So, this quantity is 1. Our length of the normal is root 2a. It's option C, root 2a. Next question. The normal of the curve x equal to a into cos theta plus theta sin theta, y equal to a into sin theta minus theta cos theta at any angle theta is such that option A, it makes a constant angle with x-axis. Option B, it passes through origin. Option C, it is at a constant distance from origin, and option D, none of these. We are given a curve in terms of parametric coordinates. X is equal to a into cos theta plus theta sin theta, and y equal to a into sin theta minus theta cos theta. Now, for this curve, we need to check whether the normal at any point is making a constant angle with x-axis, or whether it is passes through origin, or whether it is at a constant distance from origin, or it's none of the options. So, for this we have to find first slope of the normal, and if slope of normal is independent of theta, we can say it is option A. Otherwise, we have to find equation of the normal and check between the options B and C. So, let us start from the slope. Slope of normal is given by minus dx by dy, which is minus dx by d theta minus of a into differentiate cos theta plus theta sin theta. Cos theta derivative is minus sin theta, UV rule, derivative of theta is 1 into sin theta minus sin theta gets cancelled, plus theta into derivative of sin theta, which is cos theta. So, this is theta cos theta divided by dy by d theta. dy by d theta is differentiate a into a gets cancelled, derivative of sin theta is cos theta minus apply UV rule, cos theta gets cancelled, minus theta into derivative of sin theta is cos theta is minus sin theta. So, this will become theta sin theta. Theta also gets cancelled. It is minus cot theta. Slope is minus cot theta, which is independent, which is not independent of theta, which is dependent on theta. So, it can't be option A. It is not making a constant angle with x-axis. Angle is dependent on theta. Now, let us find the equation and see whether it passes through origin or not. Equation is given by y minus y1. y1 is a into sin theta minus theta cos theta equal to slope is minus cot theta into x minus x1, which is x minus a into cos theta plus theta sin theta. Let us cross multiply. Equation would be minus x cos theta, when I bring it this side, x cos theta, y sin theta minus a sin theta into sin theta minus a sin square theta, and this is plus a sin cos square theta. On this side it becomes minus a cos square theta and cos square theta plus sin square theta is 1. So, this is minus A theta cos theta sin theta plus A theta cos theta sin theta. Here again we have A cos theta theta sin theta. These two terms they get cancelled. So, equation of the normal is x cos theta plus y sin theta equal to A, or x cos theta plus y sin theta minus A equal to 0. So, this line does not pass through origin. When I substitute 0 comma 0, I get A which is not 0. So, the line does not pass through origin. And we can see this line to be in the normal form, x cos theta plus y sin theta equal to A. So, perpendicular distance from origin is A, which is a constant. So, it is a constant distance from origin, hence our option is C. Next question, the slope of the tangent to the curve x equal to 3t square plus 1, y equal to t cube minus 1, yet x equal to 1 is option A 0, option B half, option C infinity, option D minus 2. We need to find slope of the tangent to the curve x equal to 3t square plus 1 and y equal to t cube minus 1, yet x equal to 1. When x is 1, t has to be 0. So, we have to find at the point when t is equal to 0, slope of the tangent. Slope of the tangent is given by dy by dx. dy by dx is dy by dt 3t square divided by dx by dt 60. When t gets cancelled, 3 goes twice, t by 2, and when t is 0, dy by dx is 0. Slope of the tangent is 0, which is option A. Next question, an equation of tangent to the curve y is equal to x power 4 from the point 2 comma 0 not on the curve is option A y equal to 0, option B x equal to 0, option C x plus y equal to 0, and option D none of this. We are given the curve y is equal to x power 4. 2 comma 0 obviously is not a point on the curve, it is an external point, and from this point we are drawing tangents to the curve. So, just for the sake of answering the question, it is a very easy question wherein y equal to x power 4 we know the graph. This is how it looks, and 2 comma 0 is a point on x axis. So, directly we can see x axis is a tangent line to this graph. So, answer is x axis y equal to 0 or option A. Next question, the angle of intersection of the curves y equal to x square and x equal to y square at 1 comma 1 is option A tan inverse 4 by 3, option B tan inverse 1, option C 90 degrees, and option D tan inverse 3 by 4. We are asked to find angle between the curves y is equal to x square and x equal to y square at the point 1 comma 1. Both the curves are parabolas, y equal to x square and x equal to y square, and both of them they intersect at 1 comma 1 and 0 comma 0. We are asked to find the angle of intersection at the point 1 comma 1. Angle of intersection is nothing but angle between the tangents. So, let us find slope of the tangents at 1 comma 1 to both the curves. Slope of the tangent here m1, dy by dx is 2x, x coordinate is 1, so slope of this tangent is 2. Differentiate this curve, dx by dy is 2y, or dx by dy is 2, or dy by dx is 1 by 2, or slope of the tangent m2 is 1 by 2. Now, angle between the tangents tan theta, it is given by modulus of m1 minus m2 by 1 plus m1 m2, angle between lines formula. So, it is 2 minus half divided by 1 plus 2 into half, which is 1, or tan theta is 3 by 4, or theta is tan inverse 3 by 4, which is option D. So, answer is D. Next question, the abscissa of the points where the tangent to the curve y equal to x cube minus 3x square minus 9x plus 5 is parallel to x axis. Option A, x equal to 0 and 0. Option B, x equal to 1 and minus 1. Option C, x equal to 1 and minus 3. And option D, x equal to minus 1 and 3. We are asked to find the abscissae of the points, x coordinates of the points, where the tangent is parallel to y axis, that is, slope of the tangent has to be 0. Slope of the tangent, we know it is given by y dash dy by dx. Differentiating the curve, it is 3x square minus 6x minus 9. We want this to be 0, slope of the tangent to be 0, tangent to be parallel to x axis. 3 gets cancelled, x square minus 2x minus 3 equal to 0, or it is x minus 3 into x plus 1 equal to 0, x is minus 1 or 3, which is option D. So, answer is D. Next question, if the curve y is equal to a power x and y equal to b power x intersect at an angle alpha, then tan alpha is equal to option A minus b by 1 plus ab, option B log a minus log b by 1 plus log a log b, option C a plus b by 1 minus ab, and option D log a plus log b by 1 minus log a log b. We are asked to find the angle of intersection of the curves y is equal to a power x and y is equal to b power x. First, let us find where these curves intersect. Now, y is equal to a power x, exponential curve. Assuming that a is greater than 1, this is how the curve will be. And b power x is also an exponential curve. And all these curves, we know they pass through the point 0, 1. When x is 0, y will be 1 in both the cases. So, point of intersection is 0, 1, and at 0, 1 we need to find angle between these two curves. Differentiating first curve, dy by dx, slope of tangent, let it be m1, dy by dx at 0, 1. Differentiating a power x, we have a power x log a, and when x is 0, it will be simply log a. So, derivative at 0, 1 for the curve y is equal to a power x is log a, and derivative for the curve y is equal to b power x, y dash is b power x log b, slope of tangent m2 is dy by dx at the point 0, 1. So, b power x log b, when we put x equal to 0, becomes log b. So, angle between the curves, we know tan theta it is given by, here angle between the curves is called alpha. So, tan alpha it is given by modulus of m1 minus m2 log a minus log b by 1 plus m1 m2, which is log a log b. So, answer is log a minus log b by 1 plus log a log b, which is option B. So, answer is B. Find the equation of the tangent at minus 4, minus 4 on the curve x square is equal to minus 4y. Option A 2x plus y plus 4 equal to 0. Option B 2x minus y minus 12 equal to 0. Option C 2x plus y minus 4 equal to 0. And option D 2x minus y plus 4 equal to 0. We are asked to find tangent at the point minus 4, minus 4 on the curve x square is equal to minus 4y. Equation of tangent is y minus y1 y plus 4 is equal to m into, m is slope of the tangent, differentiate the curve, 2x is equal to minus 4 dy by dx, or dy by dx is equal to minus x by 2, minus x by 2, x is minus 4, minus x is 4 by 2, that makes it 2 into x plus 4. Y minus y1 is equal to m into x minus x1, that is the tangent equation. So, tangent equation is 2x minus y, bring it to the other side, 8 minus 4 plus 4 is equal to 0. So, equation is 2x minus y plus 4 equal to 0, which is answer D. Next question, find the point at which the tangent to the curve y is equal to 2x square minus x plus 1 is parallel to y equal to 3x plus 9. Option A 2 comma 1, option B 1 comma 2, option C 3 comma 9, and option D minus 2 comma 1. We need to find coordinates of the point on the curve y is equal to 2x square minus x plus 1 at which the tangent is parallel to the line y equal to 3x plus 9. That is, slope of the tangent has to be 3. So, differentiate the curve. Slope of the tangent we know it is given by dy by dx. dy by dx is 4x minus 1 which is equal to 3, or x is 4 by 4 which is 1. And when x is 1, y coordinate would be, substitute x equal to 1, 2 minus 1 plus 1, y coordinate would be 2, or the point is 1 comma 2 which is option B. So, answer is option B. Next question, at what point on the curve x cube minus 8a square y equal to 0, the slope of the normal is minus 2 by 3. Option A comma A, option B 2a comma minus a, option C 2a comma a, and option D none of these. We need to find the point on the curve at which slope of normal is minus 2 by 3. At which slope of the normal is minus 2 by 3. Slope of normal we know it is given by minus dx by dy. Differentiate the curve. 3x square dx is equal to 8a square dy, or minus dx by dy is minus 8a square by 3x square, which is given to be minus 2 by 3. So, minus and gets cancelled. Let us look at this part of the equation. 3 and 3 we can get rid of. 1 2 goes. X square is equal to 4a square, or x is 2a or minus 2a. 2a or minus 2a. So, when x is 2a, 8a cube is equal to 8a square y, or y is equal to a. 8a square gets cancelled, y is equal to a. So, one point is 2a comma a, which is there in the options as option C. So, answer is option C. Next question, the length of the normal at point T of the curve x equal to a into t plus sin t, y equal to a into 1 minus cos t is option A sin t, option B 2a sin cube t by 2 secant t by 2, option C 2a sin t by 2 tan t by 2, and option D 2a sin t by 2. In this question we are asked to find length of the normal to the curve x equal to a into t plus sin t and y equal to a into 1 minus cos t. So, both the curve is given parametrically and we are asked to find length of the normal. Length of normal we all know it is y into root over 1 plus m square, where y is y coordinate of the point and m is dy by dx. So, dy by dx is dy by dt divided by dx by dt. dy by dt, differentiating this, a into derivative of 1 is 0 minus cos t, derivative is sin t, divided by a into 1 plus cos t, a gets cancelled, dy by dx is sin t by 1 plus cos t. See, whenever we see 1 plus cos t in trigonometry, we replace this by 2 cos square t by 2, and sin t can be written as 2 sin t by 2 cos t by 2, sin 2 theta formula. 1 cos t by 2 gets cancelled, 2 gets cancelled, and this is tan t by 2. So, length of the normal is given by y coordinate, which is a into 1 minus cos t is 2 sin square t by 2, 2 sin square t by 2 into root over 1 plus m square, m is tan t by 2, root over 1 plus tan square theta is secant theta. So it is secant t by 2. So 2a sin square t by 2 into secant t by 2, which is option C. Next question. The tangent drawn at the point 0, 1 on the curve y is equal to e power 2x meets x-axis at the point. Option A, half comma 0. Option B, minus half comma 0. Option C, 2 comma 0, and option D, 0 comma 0. The tangent at the point 0, 1 on the curve y is equal to e power 2x. We are asked to see where this tangent cuts x-axis. At the point 0, 1 to the curve y is equal to e power 2x, it's an exponential graph. We are asked to find the coordinates of the point where this tangent cuts x-axis. Let us find the tangent equation. Tangent equation is given by y minus y1 is 1, is equal to m into, m is differentiate this curve, dy by dx is 2 e power 2x, and when x is 0, e power 2x is 1, so 2 e power 2x becomes 2 into x minus 0, which is x, or this tangent equation is y is equal to 2x plus 1, and it cuts x-axis at the point where y coordinate is 0 and x coordinate would be minus half. Y coordinate is 0, x coordinate is minus half. So it cuts at the point minus half comma 0, which is option B. So answer is option B. Next question. The equation of tangent to the curve 1 plus x square into y equal to 2 minus x, where it crosses the x-axis is option A, x plus 5y equal to 2, option B, x minus 5y equal to 2, option C, 5x minus y equal to 2, and option D, 5x plus y minus 2 is equal to 0. We have to find equation of tangent to this curve at the point where this curve crosses x-axis. At the point where the curve crosses x-axis. Now at the point where the curve crosses x-axis, curve is 2 minus x by 1 plus x square. When the curve crosses x-axis, y coordinate at that point would be 0, and for y coordinate to be 0, x coordinate should be 2. So we have to find tangent at 2 comma 0. Tangent at 2 comma 0. Find dy by dx. Y dash is equal to, we can use u by v rule, 1 plus x square whole square, 1 plus x square into derivative of 2 minus x, which is minus 1, minus 2 minus x into derivative of 1 plus x square, which is 2x, at the point where x is 2. So the slope would be 5 square 25 minus 5, 2 minus 2 is 0, 5 goes 5 times, minus 1 by 5. So slope of the tangent y dash is minus 1 by 5 at this point. And equation of the tangent would be y minus y1 is 0 equal to m into minus 1 by 5 into x minus 2, which is 5y plus x is equal to 2. So equation of the tangent is 5y plus x equal to 2, which is option A. So answer is A. Next question. Find equation of the tangent to the curve y is equal to b e power minus x by a at the point where it crosses y axis. Option A, ax plus by is equal to 1. Option B, ax minus by is equal to 1. Option C, x by a minus y by b equal to 1. And option D, x by a plus y by b is equal to 1. We need to find equation of the tangent at the point where this curve crosses y axis. At the point where the curve crosses y axis, x coordinate would be 0, and putting x coordinate equal to 0, e power minus x by a is 1 and y coordinate would be b. So we want equation of the tangent at the point 0 comma b. We want equation of the tangent at the point 0 comma b. So equation of tangent is given by y minus y1, y minus b is equal to m into slope of the tangent, differentiate y dash b into derivative of e power minus x by a is e power minus x by a into minus 1 by a. So minus b by a e power minus x by a when x is 0 becomes 1 into x minus a, which is x minus 0. So equation of the tangent, it is given by ay plus bx is equal to ab, or x by a plus y by b is equal to 1, which is option D. So answer is option D. Next question. Find the angle of intersection of the curves y equal to x square, 6y is equal to 7 minus x cube at the point 1 comma 1. Option A pi by 4, B pi by 3, C pi by 2 and D pi. So at the point 1 comma 1, we want angle of intersection between these two curves. Fortunately, point of intersection is given, otherwise we would have to find point of intersection by substituting y as x square in this equation. You get x cube plus 6x square minus 7 equal to 0. By inspection, x equal to 1 is a root from which we can get one point of intersection 1 comma 1. Y is equal to x square is one curve, and the other curve is cutting it at the point 1 comma 1. It's a cubic curve. We are already given the point of intersection, so we have to find angle between the tangents, and angle between the tangents, it is given by m1 minus m2 by 1 plus m1 m2, where m1 and m2 are slopes of these two curves. Now differentiate this. Dy by dx m1 is equal to 2x and x is 1. So slope of tangent at the point 1 comma 1 to the first curve is 2. Differentiate second one. 6 dy by dx or 6 m2 or m2 is equal to minus 3 x square by 6, and at x equal to 1 it is minus 3 by 6 or minus 1 by 2. Now you can see slope of one tangent is 2 and slope of other tangent is minus 1 by 2. So product of the slopes is minus 1. The tangents are perpendicular to one another, or angle between the tangents is pi by 2. So our answer is pi by 2, which is option C. So answer is option C. Next question. The tangent to the curve y is equal to 2x square minus x plus 1 at a point P is parallel to y equal to 3x plus 4. Then the coordinates of P are option A 2 comma 1, B 1 comma 2, C minus 1 comma 2 and D 2 comma minus 1. It is given that the tangent to this curve at a point P is parallel to y equal to 3x plus 4. So at P, the tangent line is parallel to y equal to 3x plus 4, or slope of the tangent. Slope of the tangent is given by dy by dx. Differentiating this, it is 4x minus 1 is equal to 3, or x is equal to 1. And when x is 1, y coordinate of the point would be 2 minus 1 plus 1, which is 2, or the point is 1 comma 2. So coordinates of P are 1 comma 2. So option is B. Answer B. Next question. For the curve xy is equal to c square, the subnormal at any point varies as option A x square, option B x cube, option C y square, and option D y cube. Subnormal at any point for the curve xy is equal to c square, we should see if at all it is proportional to x square or x cube or y square or y cube. Let us see. Subnormal, length of subnormal, it is given by y into m, where y is y coordinate of the point on the curve and m is dy by dx. So find dy by dx. Y is equal to c square by x, or dy by dx is equal to minus c square by x square into y coordinate, it is given by c square by x, and this number has to be positive. Length is always positive, so put a mod. So y is c square by x, dy by dx is minus c square by x square. Altogether length of the subnormal is c power 4 by x cube. Length of the subnormal is c power 4 by x cube. Now, subnormal is proportional to x power minus 3, or 1 by x we can replace it by y by c square, or this length is equal to c cube by c power 6 by x cube, we can replace it by y cube divided by c square. So, subnormal length we can see it is proportional to y cube. Its answer D. So, answer is option D. Next question. The angle between the curves y is equal to sin x and y equal to cos x is option A tan inverse 2 root 2, option B tan inverse 3 root 2, option C tan inverse 3 root 3, and option D tan inverse 5 root 2. We are asked to find angle of intersection between the curves y is equal to sin x and y is equal to cos x. We know y equal to sin x and y equal to cos x intersect at infinitely many points, one of which is x equal to pi by 4. When x is pi by 4, sin x is also 1 by root 2 and cos x is also 1 by root 2. So, the curves y equal to cos x and y equal to sin x intersect at the point x is pi by 4 and y coordinate is 1 by root 2. So, we are asked to find angle between the tangents at this point. Angle between the tangents, it is given by find slope of tangent to one curve at pi by 4 comma 1 by root 2, and also slope of tangent to the other curve at pi by 4 comma 1 by root 2. M1, differentiating sin x we get cos x. Cos x when x is pi by 4 is 1 by root 2. M2, differentiating cos x we get minus sin x. Minus sin x when x is pi by 4 is minus 1 by root 2. Angle between the tangents, tan theta is equal to modulus of m1 minus m2, 1 by root 2 plus 1 by root 2 divided by 1 plus m1 m2, which is 1 plus 1 by root 2 into minus 1 by root 2, 1 minus 1 by 2. So, this is numerator is root 2, this 2 goes up, 2 root 2 by 2 minus 1, tan theta is 2 root 2, or theta is tan inverse 2 root 2. So, angle is tan inverse 2 root 2, which is option A. Answer is option A. Next question. If the normal to the curve y square is equal to 5x minus 1 at the point 1 comma minus 2 is of form ax minus 5y plus b equal to 0, then a and b are option A 4 comma minus 14, option B 4 comma 14, option C minus 4 comma 14, and option D minus 4 comma minus 14. It is given that for this curve y square is equal to 5x minus 1, normal at the point 1 comma minus 2, it is of form ax minus 5y plus b equal to 0. So, let us find normal at 1 comma minus 2. Normal at any point it is given by y minus y1, y plus 2 is equal to m into m is minus dx by dy, minus 1 by slope of tangent. Slope of normal is minus 1 by slope of normal. Differentiate 2y dy by dx is equal to 5, or dy by dx is equal to 5 by 2y, or minus dx by 2 dy is equal to minus 2y by 5. Y is given to be minus 2. So, minus 2 into minus 2, that makes it 4. So, slope of normal it is 4 by 5 into x minus 1. Cross multiply, equation of normal would be 5y minus 4x. This is 10, 14 plus 14 equal to 0. But it is given that the normal is of the form ax minus 5y plus b equal to 0. So, to make that, let me multiply throughout by minus sign. It is 4x minus 5y minus 14 equal to 0. So, a is 4 and b is minus 14. A is 4 and b is minus 14. It is option A. Next question. For the curve given by x plus y is equal to e power xy, the point at which the tangent is parallel to y axis is Option A 0, 1. Option B 1, 0. Option C 1, 1. And option D -1, -1. We have to find the point on this curve, the tangent at which is parallel to y-axis. Tangent at which is parallel to y-axis. Now, for the lines parallel to y-axis, dy by dx is not defined, or dx by dy has to be 0. Dx by dy has to be 0 for the lines parallel to y-axis. So, let us differentiate this equation with respect to y. When I differentiate this with respect to y, dx by dy plus 1 is equal to e power xy into derivative of xy is y into derivative of x dx by dy plus x into derivative of y, which is 1. Now, dy by dx by dy we know it is 0. Putting it is 0, 1 is equal to e power xy into this quantity is 0 into x. So, this is possible when x is 1 and y is 0. So, y is 0 and x equal to 1 will give us dx by dy to be equal to 0. And to check whether this is a point on the curve or not, when x is 1, y is 0, e power xy is also 1, 1 equal to 1, it satisfies both the conditions. The point is 1, 0, which is option B. Correct answer is option B.